All right, in section 7-5, proportions in triangles. All right, so circle the model that can form a proportion with 10 over 15. All right, so the one that represents 10/15, which is equivalent, is this one. Circle the ratios that you can use to form a proportion. So 3/4 and 75 over 100. All right, and then cross out the proportion that does not have the same solution as the others. This one. All right, so a bisector divides a whole into two equal parts. A bisector is a point, a segment, a ray, or a line that divides an angle or a segment into two congruent angles or segments. All right, so ray BD is the bisector of angle ABC. ABC is bisected by ray BD. Ray BD bisects angle ABC. All right, the side-splitter theorem and its corollary. So the side-splitter theorem states, if a line is parallel to one side of a triangle and intersects the other two sides, then it divides those sides proportionally. So if I know RS is parallel to XY, then I know XR over RQ equals YS over SQ. So if XR equals 4, RQ equals 4, and YS equals 5, then SQ must also equal 5. And then conversely, if XR equals 3, RQ equals 6, and YS equals 4, then SQ must equal 8. So corollary. So now this is extended. So instead of just having two parallel lines, what if I have three parallel lines? Then I can set up this ratio. All right, so let's complete each proportion. We know BC is to AB as XY is to WX. We know CB is to BA as YX is to XY, and AC is to AB as WY is to WX. All right, so here is using the side splitter to justify and solve for A. So we first set up the proportion A is to A plus 4, which equals 12 over 18. This is called the side splitter theorem. So we're going to cross products property. Okay, by cross multiplying, we're going to then subtract 12 from both sides. 12A, excuse me. Then we're going to simplify. Then we're going to divide each side by 6. And then we're going to simplify. All right, let's try using this in a problem. So the campsites are shown below in the diagram. What is this length of site C along the road? So what is this length here? Okay, or I guess we're calling that Y. So Y over 7.2 is equal to 6.4 over 8. Cross multiply, so 8 times Y equals 46.04. Divide both sides by 8, and we have Y equals 5.76. So the length of site C along the road is 5.76 yards. All right, if a ray bisects an angle of a triangle, then it divides the opposite side into two segments that are proportional to the other sides of the triangle. So we know this. Let's try this problem. We know we have an angle bisector, so we can set up the proportion. 9.6 is to 16 as Y is to 24. Cross products property, multiplying both sides, you get 230.4 equals 16Y. Dividing both sides by 16, and you get Y equals 14.4. So the value of Y is 14.4. Okay. So circle the proportion we can use to solve the problem, so we can use this proportion. So let's solve it. 10 over x plus 10 equals 30 over 45. Cross multiplying, and you get 450 equals 30x plus 300. Subtracting 300, you get 150 equals 30x. Dividing by 30, you get x equals 5. Okay, so what happened here? So classmate says you can use the side splitter theorem to find both x and y in the diagram. Why can we not? So cross out the lengths that are not parts of the sides intersected by the parallel line. Well, 7 is not part, and x is not part. Can you use the side splitter theorem to solve for x? No. Can you use it to solve for y? Yes. So what's wrong with the classmates? Well, you can't solve for x. That'd be y.